My name is Hall Cushman. I'm a professor of biology at Sonoma State University. And what I'd like to do is talk to you about some research that a colleague and I here at Sonoma State, Ross Mintemeyer, and I are working on. It has to do with how the pathogen, P. ramorum, that causes sudden oak death, how does this pathogen move throughout the landscape? There's a great deal of interest in that topic because it's obviously very important. Those factors that spread this pathogen through the landscape are going to be very important to understand. If we understand these forces that move the pathogen throughout the landscape, we have a better chance of controlling the disease and managing the situation. So a great deal of research to date has focused on the role of abiotic factors, things like streams, wind, and wind-blown rain. The role that these factors play in moving Phytophthora ramorum around. Those are clearly very important factors, and I don't want to at all de-emphasize their importance. But my colleague Ross Mintemeyer and I have been very interested in the role of vertebrates, the roles that they play, if any, in spreading the disease around. And here we're talking about ourselves, humans, as well as other vertebrates such as deer, turkeys, wild pigs, birds. Our research to date has focused most intensively on humans, and that's where we have the most results so far. And we've obtained 3 lines of evidence so far that suggest that humans play a very important role in spreading Phytophthora ramorum, this fungus-like disease that causes sudden oak death. The first line of evidence is that the pathogen is found more commonly in soil on hiking trails than immediately off hiking trails. And the most logical explanation for this is that we humans, when we go to recreational areas to hike, we are tracking the pathogen around. We are moving it on the soles of our feet, perhaps on the tires of our mountain bikes. We're moving it throughout the landscape. So that's the first line of evidence. But all that shows is that we're moving the pathogen around. But what we need to look at is whether or not our activities lead to greater disease in host plants, in trees. And so what we did is move up to a more landscape level and showed that study plots that are found in areas that experience high visitation rates, such as in state parks or in county parks or even in national parks, those areas tend to have greater symptoms of sudden oak death than plots that are occurring in areas that experience low visitation rates. So these would be areas such as on private land or on public land that is not open to the public. So that was the second line of evidence. Basically, areas which we frequent heavily have high levels of symptoms of the disease. So the third line of evidence, suggesting that humans play an important role in the spread of this disease, is that we have found that areas, wildlands, that are surrounded by high human density, they have greater levels of infection than wildlands that are surrounded by lower human densities. And that makes sense. Wildlands that are surrounded by high human density are going to attract more people that come to those parks, those wildlands, to recreate, whether it's mountain biking or horseback riding or hiking. All of those activities, we feel, will bring inoculum from this pathogen into the wildlands, but also move it around. And so those 3 lines of evidence, to us, paint a strong picture suggesting that humans, people, through recreation, are playing an important role in spreading the pathogen and also spreading this disease. The sad irony of our work is it suggests that nature lovers, people that love to hike, mountain bike, horseback ride, that these people, myself included, inadvertently have the potential to bring the pathogen into forests and to disperse that pathogen throughout the landscape, leading to greater disease. And it really is sad, but our data certainly suggests that that's going on here. And these results that we've obtained really present resource managers in charge of these public areas. They present a tremendous conundrum that they have to deal with. And Ross and I feel that there are really only 3 options that these resource managers have to deal with this problem. One is to do nothing, and that may be the easiest road to go. But doing nothing may lead to greater disease spread, and those resource managers taking that avenue may open themselves up for criticism for inaction. A second tact, which also has some downsides associated with it, is to implement some sort of shoe cleaning procedure at the parks. This is going to take a great deal of vigilance and time and money on the part of resource managers, but it has been shown to be an effective way to remove the spores of Phytophthora from shoes and from the tires of mountain bikers. A third possibility, also unpopular and difficult to implement, would be to close high-use areas during the period of the season where inoculum is most abundant. And out here in California, that would be probably, say, from February to March, perhaps into April. During this period is when inoculum is being produced in great abundance and the potential for dispersal is possible. So if we could restrict human activity during that period, it would be potentially an effective management tool. Now that would be incredibly unpopular with the general public. So none of these options that we can come up with are at all attractive, but they are nonetheless what's available to us.